We're going to talk now, if you'll take a look at your worksheet, we're going to move into modeling area model and modeling standard algorithm. In 5th grade, you are expected to be fluent in the standard algorithm for multiplying 2-digit by 2 digits. So what we need to make sure is that we have that conceptual understanding, that we're not multiplying when we're looking at a problem, that we're not just multiplying the digits, but we're paying attention to the place value. So let's take a look at the first one, and we're going to build some conceptual understanding, just like we've been doing with our problems up above where we were multiplying by powers of 10. We're going to take a look at our area model. And with our area model, what I want us to think about is, once again, decomposing our numbers so that we can get them into more manageable pieces in our powers of 10. Yes? Okay. So talk to me about 64 times 73. What am I going to decompose those numbers into to make them more manageable for me? Yes, ma'am.
64 is going to be 60 plus 4.
Okay, so let's write that down for a minute. Let's write down, let me use a dark marker. Let me write down 60, maybe, come on, 60 and 4. Now, I want us to think about for a moment the value of 60 and 4. What is a 60? What is a 60?
6 tens.
It's 6 tens, okay, it's 6 tens. How about, if I'm thinking about the quantity of 60, is that a lot more than 4 or a little bit more than 4? Are they equal, pretty close, or is it significantly more? Significantly more. So when we're drawing our lines, instead of drawing them straight down the center, vertically and horizontally, what I would like us to do is to think about the amount of how much larger that number is. So when we do our area model, let's really show that a 60 is significantly larger than a 4. Let's draw our line pretty far over there to the right to show that a 60 is significantly larger than a 4. Because we expect our product to be larger for that number. Okay, so what's our next number that we're going to decompose, Joelle?
73.
A 73. So what are we going to decompose that into?
Into 70.
Into a 70 and a 3. Okay, so it's the same concept. What is a 70, Sebastian?
A 70 is 7 tens.
7 tens. So tell me about the relationship between a 3 and a 70. Are they close to each other in quantity?
The 70 is significantly higher.
The 70 is significantly more. If I was going to tell you, you want $3 or $70?
70.
Where are we going?
70.
Right? So we want significantly more. So we're going to make that section larger. So we're going to, once again, make that section larger. Now we are ready to use our method that we already know how to do, and we're ready to start filling in the blanks. Let's make this really simple here for a minute. Are we going to think about 60 times 70, or are we going to think about 6 times 7?
6 times 7.
Do you want to do 60 times 70 in your head?
No.
What do you want to do? 6 times 7, yes? Because my brain likes little numbers, right? Then I want to think about really what the value of those numbers is. What is the power of 10? Okay, so let's think about that. So 6 times 7 is how much?
42.
42. The question is, where am I going to go as far as powers of 10? How many powers of 10 do I have?
2.
So what am I going to do to my 42? I need to show that it has 2 powers of 10. Yes? Correct? Okay, so now I'm going to move on. You're going to move on with your partner. Let's do our shoulder partner and keep going.
Okay, good. I'm right there. Equals 18 plus 0 4 times 7 equals 28 plus 0 4 times 3 equals 12. Then you add 10. because they have to do something with the extra power of 10 from the 70.
Yeah, and then you get 280. And then we're gonna multiply 60 times 3.
So what are these things
we're
called
gonna
that you have
do
here? Are these our
6
answers?
times 3.
Or they are
Because we
partial
like small
products?
numbers.
There are partial products. So what are you going to do? Are you done?
No.
So what are you going to do now? You're going to add them together. Okay, do we all come up with, do we agree? Okay, so what are we going to do with those numbers? What are these numbers right now? Are they our final answer?
No.
What are they?
We're going to add them together.
They're products, but they're partial products, correct? So we need to add them together to get an actual whole product. Is everyone ready for that? Okay. How you doing, Andrew?
You got 4,600.
So it looks like we all took our partial products and added them together. And we did an extremely good job. Lovely, lovely, lovely. You two have two different answers. Can you talk to each other?
What do you have?
Oh, like this table, talk to each other.
4,672.
Okay, what were your answers?
Okay, you've got a different answer than she has.
70.
Nope, right, no, you do it here. You got it right here, but you
Yeah.
voiced this number here.
Oh, you got the same. You got the same answers in the box, but
Then 60
Okay, we're not
times
there
3.
yet, Joelle. We're not there yet.
4,280
No, 60 times 3.
Oh, Bella, would you go in and finish filling out my chart for me, please?
So then you would do. This is 2, 8 plus 8 is 16.
Okay, as everyone says, please get some table consensus at your table as to what your product
4
is.
plus 2.
I know what you did wrong.
Yeah. Okay, can you also write down your partial products?
Yes.
So we've come to the consensus that our product is what, Tori? 4,672. We've all come to that consensus. So now what we're going to do is we're going to take that and we're going to take that knowledge and we're going to put it over to the standard algorithm. Now let me ask you a question. This is what I hear all the time. 3 times 4 is 12. So I'm going to put down the 2 and I'm going to carry the 1. Am I carrying a 1?
No.
What am I carrying? A 10. So we have to make sure that we're using that verbiage, okay? That precise mathematical language, that we are going to carry a 10. 3 times 6. Is that correct? No. 3 times 60 is how much? 180 or 18 tens. Plus 1 more 10 is 19 tens, otherwise known as 190. So when you're working through this standard algorithm with your partner, I want you to pay attention that you're going back and forth taking turns, and I want you to make sure that you're using that precise language. If your partner does not use that precise language, I want you to call them on it. Okay? In a very nice and friendly way. Remember our rules of group. In a very nice and friendly way, I want you to call them on it and say, precise language, please. Can we all practice that? Precise language, please. Okay, go ahead, please. And we're going to do this fairly quickly because we've got to get into our wets.
3 is 12, so you carry.
Shoulder.
Okay. 3 times 4 would give you 12. Then 3 times 6 would give you 18 plus that 1 would give you 19. Then you would have to put the placeholder. Then 70 times 4 would give you 200. Wait. Yeah. 4, 7 times 6 is 35. 2 is... Then 70 times 60 would give you 4,200 plus the 2 would give you...
Is it plus 2?
Plus the 20. 4 would give you 4,400.
I was right because I changed one. It's supposed to be 7 times 4. 8 and
Oh, I not messed up. Okay, the 2.
0.
Did you mess up
Then
something,
the
Sam?
90 plus the 80 would give you 170. The
How you doing, Abs?
100 plus the 400 would give you 500 plus the extra 100 would give you 600. Then you have
How you doing?
4,672.
Doing well?
How do you go?
Yes?
You would add your 2
I need a comma.
because of
Okay, question. Did we come to the same final product?
this is 8.
What is the relationship between your area model and your standard algorithm? Do you see the same partial products in them? Look at what you have in your standard algorithm and look what you have in your area model. Can you see the commonality between the partial products? You've got 2 partial products in the standard algorithm and you've got 4 partial products in the area model. But do those 2 combine together to make them? Yes. Okay. Was it a little bit more difficult to keep track of what was happening in the standard algorithm? A little bit? You tell me. You guys might be very fluent at this by this point. What do you think? No? We're good? We got it? Excellent, because by the end of 5th grade, we need to be fluent in this. Okay, we're going to move on to WEDs. We're going to move on to WEDs. So let's get ready for that. We're going to talk about Andrew and his balloons. The problem is there on your sheet so that you can talk to your partner about it. I am bringing you your sticky. You are well versed in how to deal with the WEDs. As soon as you get your sticker and your model drawn out, you may find yourself one partner. Remember, you are going to be working at these 6 tables. We can't go someplace else in the room. And it is very important that we do not talk over each other. Get your 4 boxes drawn, please. So let's talk about our problem. Andrew bought 16 bags of balloons, with each bag containing 15 balloons. He gave all of the balloons to 20 children during a school party. There were 4 more boys than girls. If each child received the same number of balloons, how many more balloons did the boys receive than the girls? Does this remind anyone of a problem that we did earlier in the week? Yes? So would we be able to use that as a jump-off point for this particular problem? Once you get your partner, make sure that you're referencing back to what we've already done before you start jumping in. You should have your wedge set up. You may get your partner. Be careful in your movement, please. 5, 4. Ooh, very loud. 3.
Sitting here.
2. You need to sit next to your partner. And 1. Who does not have a partner? There you go. You 2 get to be together. It's right over there at that table. You should be sitting next to your partner. And you may start your wets.
Okay.
We're not all talking at the same time. I should hear one person in your group talking at a time.
First, we need to do what we already know. So, he has 16 balloons. No, 16 bags of balloons.
So we could put, for an equation, 16 balloons, wait no,
16 bags.
16 bags equals
15 in each. 15.
Yeah. 15 balloons equals 1 bag of balloons. 16.
Or we can just. Okay.
15 balloons equals 1 bag.
Okay, Abby, attack it sentence by sentence. What are you going to do? Talk to your partner.
This is what I did.
Each bag containing 15 balloons.
So what equation can you write for that?
Bags just for the first one, and then one bag equals 15 balloons.
Okay, so let's write that down.
15 balloons equals 1 bag, and balloons equals...
Have you written an equation? Is
He
it
gave all the
16
balloons to 20
equals
children
15?
during school. So minus 20
No, not really.
for boys.
Have we written an equation for what we know about this yet? Could you put those two things together in an equation?
Yes.
Okay, well let's do that.
Okay, Sebastian.
Can you write an equation for these first two things? Remember, what our objective is to
16
try.
bags balloons equals 15 balloons each.
Okay, but let's think for a minute. What our objective is to take the information and try to put it into equations that we can then work with for our models.
15 times what? Because there's 15 in one bag.
Okay, I need an equation for these two things together. If there are 15 balloons in a bag and there are 16 bags, what equation can you write for that?
15
If I've got 16 bags, let's imagine these are 16 bags and there are 15 in each, what equation can I use for that? Can any of you tell me?
15 times 16.
Why would that work?
Because in each bag there's 15.
And there are 16 bags. Okay, so listen to what Bella's saying. Tell them that again, explain why it works. Have you guys come up with an equation for the first two sentences?
15 times 16 equals...
Tell me about what could you do here. Could you come up with an equation for me? Like what would the equation be?
I think it would be like, because there's 16 bags and each bag is containing 15 balloons, so maybe like 16 times 15.
Sounds valid to me. Can you explain to Maya why that works?
Because in 16, because in each bag, because each of the 16 bags.
Have you come up with an equation for this? If there are 16 bags and each bag has 15 in it, can you come up with an equation for me?
16 times 15.
Okay. Why would that help you?
Because there's 16 bags of balloons, and in each bag there's 15 balloons.
Do we need to know how many total balloons there are? Yeah, we do. So the question is this: if we have 16 bags of balloons and there are 15 in each bag, each table has told me at this point that they're going to multiply those together. I would like one of the partners to do a standard algorithm. I would like the other partner to do an area model.
I'll do an area model.
Okay, you do that. The design and I'll do the solution.
And then check your work. It would be in solve, yes. That's very good. Bella said, where would I do that computation? I would do it where? In the design. Not in the design, Andrew. In the solution section. Because what goes in our design? Our bar model. Oh, you're good. You're fine. Okay, that's a good question. Maricela says, is the cluster box or is the area model, is that still a design? It kind of is, isn't it? But it's kind of like a non-standardized algorithm. So I think you could get away probably with putting it in the design, but let's save the design space for our area, for our model drawing, okay? But good point, Maricela. Chop, 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 chop. We gotta go quick.
Okay.
We got till 1:15.
I want to do the algorithm. What you get would also go in the solution.
Why don't you do both of them over here?
me try that again.
And then we'll save this for our bar model.
Put both of them in ours. Like I would put what you did in mine. You would put
You don't need to right now. No, just make sure that you end up with the same product.
Okay, so
Andrew, you come on. You know how to do this.
15.
You said bag got.
Okay, where are you gonna go next? So now that you know this, where are you gonna go next? Don't sit there with your hands on your lap. What are you gonna do next? You're gonna check your partner and see if he's got the same thing. What is that 240? Does it say one?
I got it right. It was
I got 240.
yesterday.
Yeah.
Okay, tell me about this number. What is that?
20 divided by 2 equals...
Can we write that down? Where's your label?
10 plus 4, 2.
So how many balloons did we come up with, please?
14, 4.
You came up with 692? What did you come up with?
I did the model.
Okay, we're not doing model right now. We're trying to do either an algorithm or a box and cluster or area model. So if she did an algorithm, you want to go back and check because you need to talk to each other and talk about if you got the same answer. Amaya, go back through your steps and look again. Because does it make sense that there would be that many? Does it make sense that 16 times 15 would equal 900 something?
I said 690.
Okay, let's talk about 16. 16 would round to 20. 15 would round to 20. 20 times 20 would be 400. So 900 would be what? It'd be way too high, right? So something went wrong in your algorithm. So you want to go back and check. Okay. Once again, that comes back to that number sense. Okay. Do we have a label for what the 240 is?
What I would do was I would
240 what? Okay.
since they
Okay, let's get ready to move into our model drawing. Let's get ready to move into our model drawing. This would be a great time to reference back to the similar problem that we did earlier. This would be a great time to talk about, we have to compare the what? The boys to the girls. We have to compare them. So when we're comparing, think about when we're model drawing, do we want one long model or do we want a comparison model? If you can interpret the one long model, go for it. If you're better at interpreting a comparing model, think about that. Think about what you would prefer yourself. Go ahead. We're going to give you about 5 minutes for that. 5 minutes to get that area model, or to get that model drawn. 5 minutes.
Half of 20 is 10.
let's draw. How about we draw our area model? So, do you want to compare or? Oh yeah, that's right.
The girl's gonna be shorter, so we know that there's gonna be 4 more boys than girls. 4 less 4. So if we took 4 from 20, it's 20. That is
Is that going to equal 20? If there's 14 and 16? There's 20 altogether, right?
So,
But what can you tell me? Are there more boys than girls? How many more boys than girls are there? So how could I draw that out? Go back and look at the problem that you did earlier. Okay, so think about what we started off with. We started off with them being the same.
so there would be 8 slots in the boys.
right.
So I want you to think about employing that same strategy this time.
And 8 spots
Think
in the
about your
girls.
bars being the same and then adding on the extra. Okay?
Yeah, I think that's a good idea.
Are there more boys or more girls? Boys. Okay, so question, how could I show that in a model drawing?
Compare.
Okay, so how would I compare that to you?
Well, you would have one bar. So what did you draw?
1, 2, 4. And that just looks hideous. Okay.
4 for the
Means that whatever you've got sticking out over would be the extra boys, yeah? Make sure you label it so that it makes sense. Yes, sir. Okay, well, let's talk about it. we've got 20 kids total,
So we're
right?
20 boxes, right?
Huh?
So for 20.
Okay, well, let's just talk for a minute. We've got 20 kids total, right? Some of them are boys and some of them are
There's
girls.
4, so we can take those out,
Okay,
'cause that's
so let's
also
talk
boys.
about that. So
now
let's start
we
off with a
have
boys and a
16
girls
left.
box.
We can divide that into
Start off with a
2.
boys and a girls box.
The girls will get 8.
A boys box? We're not doing how many, we're just doing a boys and a girls box. Right?
How'd you get?
And label them.
Divide them.
Labels.
Doesn't make a difference. Make one box boys and one box girls. Now tell me about the boys. So how are you gonna show that? What are you gonna do to your boy box? Draw 4 more on in it or on the side of it? Is it 4 more in the box where it's going to make the number? Is that going to make it 4 more than the girls, or is that going to be part of the boys?
I get you now.
On the outside. So think about that.
You were right, actually. I didn't really see this.
So is this equal 20?
This, yes. This,
Okay, so how many balloons did each one get?
Wait,
I didn't count that yet.
Oh, okay, we'll get there.
wait, does that mean
So what did you tell me? You told me there's 4 more boys. So where are you going to put that on here?
There's 14.
Where are you going to put it?
I don't know.
We'll talk to Caleb. He seems to have figured it out.
And there's 8
Where if
girls.
it's
Well, okay, so this is a number. We don't know what the number is. And then so we're going to
So now
add
we
how
can
many
do
more
12
boxes over
times
here?
14.
Little boxes. How are we doing? We're getting confused. Okay. Okay, guys, let's talk for a moment. Because I'm hearing some confusion, so let me go back. Because we've got about 5 minutes before we need to be able to get there. So let me come back up here for a minute and let's talk some design. How many children are there total? 20. There are going to be 20 children total, correct? We all know this. What kind of children do we have? We have boys and girls. So take your picture and put in an indicator for boys and an indicator for girls. Do we know how many are boys and how many are girls? No. Mm-mm. So how are we going to show right now that we're just comparing them? How are we going to show that we're just comparing them and then that we're going to have 4 more boys? Steven, do you have an idea?
You would put a bar model on top and a bar model on bottom.
Okay, can you come show me that, please? Okay, can you label which one's boys and which one's girls? That's boys. And this one's girls. Why did you make the girls section smaller, Stephen?
Because there are less girls than boys.
How many less?
4.
Can you indicate that there are 4 more boys on there somewhere for me? Okay, there are 4 more boys. So let's think about these 2 boxes. What do we know about these 2 numbers then? These 2 numbers, say it louder, Sebastian. Why are they equal?
Because whenever you add on the 4 more, the boys have more.
Okay, so whenever I add on the 4 more, the boys are going to have 4 more. So what do I know about all of this together? Thank you, Stephen. What do I know about all of this together? Let me move this over. All of it together has to be how many? 20. Okay, keep going. Get that drawn down.
144.
Yeah, the boys get 144 balloons.
So if I've got the 20 and I've got the 4,
14 times
what am I going
12
to do
is
with it?
168.
If there's 12 boys and each boy gets 12 balloons, 12 times 12 equals 144.
Oh,
But there are 14.
I did 14.
No, 12 boys in all.
Yeah.
Start talking to your table of 4, if you haven't already, and start talking about how many balloons each boy and each girl gets.
Do you guys need help? I'm still drawing the model. Okay.
Okay, so if there are 240 balloons and there are 20 children, how many balloons does each child get?
12.
Okay, so you've decided that that's 12. So if this and this equals 20, but this is 4 more, how are you going to decide how many girls there are and how many boys there are? What are you going to do with that 20 and the 4?
You can
Say a little louder.
you can subtract
Okay, why would I subtract it?
To see how many, because there are 4 more boys and girls.
Okay, so take their 20 and subtract it. Subtract the extra boys. What did you get?
16.
16. So that means that these 2 boxes together each have to be 16. So if they're both together 16, what's the question? How much are they separately? Look up here, let me show you. You've already told me that this is 4, right? And you've told me that this together is 16. So how much is each one separately? 8. What did you guys come up with? How many girls are there? There are 8, so let's write that down. And how many boys are there? 12. 12. Okay. So if you determine how many balloons each child gets, how many balloons does each child get? 12. So how many more balloons are the boys getting? There we go. You have a solution. Talk to the ladies behind you. What did we determine? 48. And we all agree on that? You're missing some stuff on your model. Can you guys talk to each other about your models? Because we're missing some stuff over on the side. What did you guys decide?
The boys get 48.
Why?
Once you find out how many balloons the boys got, you have to find out how many balloons the girls get and subtract the girls' balloons from the boys' balloons.
Okay. Can I ask you another question? Could I just decide how many balloons each child gets, regardless of whether they're a boy or a girl, and then just figure out how many extra boys there are and multiply that by 12? 12 times 4.
48.
Right? Exactly what you did, but think about, we talk about this all the time, right? Thinking about trying to be as efficient as you can. Number sense, trying to be as efficient as you can. Because I really don't even need to figure out the rest of them unless I want to check, right? If I want to check, I've got to be able to do that. Okay. Beautiful.
I did that. Oh, wait.
Let's see. Stephen, will you come back up and plug in the rest of our stuff on this model? I'm interested, because we've got about 3 minutes left of class, and then we're going to answer our reflection questions for homework. I am interested in who has a different model than the one that we've drawn up here. So if you've got a different model than the one we've drawn up here, I would like you to raise your little paw in the air, and I'm going to come take a look at you. How is that different? How is it different? Anyone do something other than bar?
Miss Ussary?
How is it different?
Miss Ussary?
We have no school tomorrow.
Oh, Monday. Ignore me. Monday. Where's your numbers in there?
Oh, I'm gonna do
I saw someone who had like little circles and stuff. You erased the circles. Okay. What do you have going here, Abs?
I was just going to say, maybe get a tissue.
Yes.
So that's 12.
You erased your other idea. Do we all went bar model? We've been doing so many bar models. I'm not surprised we all went bar model. We do love bar models. Okay, Steven, tell me what we've got going here. Sorry, let's pull it together. Steven, tell me what we've got here.
Well, what we have here is we have to have, there are extra boys, so there's going to be one part sticking out, and so one part of the boys has to be equal with the girls, so you can see what's equal, what both of them have, and then you find out what the rest of it is.
Great. Okay, who can tell me their computation that they used to determine how many balloons each child used? Evan, come on up here and show us. Computation for how many balloons each child received. You need to make sure that you're adding all of your parts to know how many each balloon each child receives. Can you add your sections to tell me how many numbers are there? I need your numbers in your boxes.
Okay.
I need those full labels. Stephen, can you fill in how many balloons each child gets, please? Congratulations. Can you tell me how many balloons each child gets in your model card, please? So, Evan, how many balloons does each child get?
12.
12. Okay, so if each child gets 12, and my question is, how many more balloons do the boys get? Where am I going to go with that from there? Marcella? Where am I going to go from there? How many more balloons do the boys get? You want to phone a friend? Or you got it? Give her a minute. How many more boys are there, Marcella? There's 4 more boys. So if each of those 4 boys gets 12 balloons, how many more balloons do the boys get?
48.
48. Sebastian, tell us about your long way of doing it.
Well, I figured out how many balloons there were in total. Then I divided that by 20 to find out how many balloons each person got.
Which is where we are right now, which is 12, yes.
Then I figured out how many boys there would be and how many girls there would be. Then I multiplied the 12, which is how many balloons each child got, by the 12 boys there were, and I got 144. Then I subtracted the boys' balloons from the total and got 96, which was how many balloons the girls got. Then I subtracted 196 from 144 and I got 48.
Okay, so Sebastian figured out not only how many extra balloons the boys got, how many all the boys got, and how many all the girls got. Wonderful math. Beautiful. Do we have to go there?
No.
Okay, it's great that he went there because that's how his brain works. But do you have to go there? So always go back to what the question is asking you. The question wanted to know how many balloons more the boys got. So you should have your statement filled in at this point, and we should be ready for reflection. There is a quick exit ticket on the back of your sheet. If you'll take a look at that. What is something new that you learned today? Explain. What is something that you now understand better than you did before? Explain. Yes, sir.
What is